In order to have a deep and solid understanding of the phases of the moon and how that works, I think it's really important to understand the relationship between the phase of the moon's position in the sky, and the time of day. So that's what we want to do. The relationship. The phase of the moon, the position in the sky. So phase of the moon, waxing crescent, waning gibbous, full, first quarter, third quarter, that kind of thing. Position in the sky, rising in the east, setting in the west, high in the south, not visible, that sort of thing. And the time of day. Noon, midnight, sunrise, 11 p.m., 6 a.m., that sort of thing. There is a clear relationship between these three things because these are all connected based on geometry, based on the physical positions of where the moon has to be and the earth has to be and the sun has to be in order to make these things happen. So as a result, if you know any two of these, you can make a pretty good estimate about the third one. You can figure out what the third one is. So using any two, you can figure out the third using a diagram. And if you can do that, now you really understand at a deep, solid level exactly what the phases of the moon are and how it works and how this connects to the time of day and all these sorts of things. So let's do an example of that. So suppose I want to, my goal is going to be the phase of the moon. So how do I want to do that? And my goal is going to be the phase of the moon, so I need to be told what is the time of day. So let's say, if it's a phase of the moon, let's say the time of day, I'm going to say it is 6 p.m. And let's say I'm going to tell you the position of the moon in the sky. And so this is the time. And the position of the moon in the sky, I'm going to say the moon is highest. The moon is at its highest point in the sky, high to the south. High in the south. So that's the position in the sky. Now, using these two pieces of information, I can draw a diagram and I can figure out what the phase of the moon must be. Here's how it works. We lay down the earth. There's the earth. Noon, midnight, sunrise, sunset, sunrise, all that sort of thing. We put in the sun, our friend Mr. Sun over here. What do we have? It is 6 p.m. It is 6 p.m. So based on this, well, here's noon, here's midnight, 6 p.m. So I can draw myself, drawing not to scale. There I am on the earth. So this is my position on the earth at 6 p.m. At roughly sunset, and well, it all changes based on seasons. Let's assume it's the equinoxes to make the math easier. And we're going to say the sun is highest in the sky. It's in the south at its highest point today. So that means in this diagram, the moon is basically directly overhead. So if the moon is directly overhead, well, what phase of the moon is that? Well, I know what phase that is. Here's new, here's full, here's this is a first quarter moon. So I can use these two pieces of information. Once I've drawn my diagram, if it's 6 p.m. and the moon is high in the sky, if it's roughly sunset and the moon is high in the sky, it must be a first quarter moon. The moon must be in its first quarter phase. Let's do another example. Suppose the goal is not the phase of the moon. Suppose the goal is the time of day. Time of day. All right, I want to figure out what time of day it is, and in order to do this, I need someone to tell me the position in the sky of the moon, in the sky, and I need someone to tell me the phase of the moon. Phase of moon. There it is. So position in the sky. Let's say the moon is rising in the east. Rising in the east. And let's say, what phase shall we do? Let's say it's a waning gibbous moon. Waning gibbous. So somebody says, hey, I was out the other night and I saw this waning gibbous moon and it was rising in the east. And I can say, stop right there. I can tell you what time of day you were looking. Let's figure it out. Again, lay down the earth. There's the earth. There's the sun. So what's going on here? It's waning gibbous. I know where a waning gibbous moon goes. Here's new, between the earth and the sun. Here's full, opposite the sun. Waning gibbous is somewhere over here-ish. The moon is in the waning gibbous. If it's full for like a day. It's waning gibbous for like a week as it moves from full all the way to third quarter. So somewhere over in that neighborhood. And I said it was rising in the east. Okay, so if I put myself here, well, that would be directly overhead. But it's not directly overhead. Oh, but the moon's going to rise roughly, give or take a few hours. It's going to rise about, usually the moon rises about 6 hours before it's its highest point in the sky. So that means if it's rising, well, that must have happened about 6 hours earlier. Okay, right here, this is, it's highest in the sky. That's past midnight, so I don't know, this is maybe roughly 3 a.m. or something like this. All these computations are plus or minus a few hours based on seasons and details and stuff like this. But we want to get the main idea. So the main idea is a waning gibbous moon is pretty much overhead somewhere around 3 a.m., after midnight. And so it's going to rise about 6 hours earlier. So here's where the moon would be rising. And so this is, it's late in the evening. It's after sunset, before midnight. I don't know, I'll call it 9 p.m. Something like this. Could be 10 p.m., could be 8 p.m. At some point after sunset, before midnight, that is when a waning gibbous moon will rise in the east. And so that's where you see the moon. You know, when you were over here, you couldn't see the moon. The earth was in the way. And then as you move over here, sometime late in the evening, that moon pops up. And when the moon rises in the, it's rising in the east and it's waning gibbous, it must rise sometime after sunset and before midnight. Cool. So let's see. We've just done the time of day. Now my goal, let's see, we did the goal of figuring out the phase of the moon, the time of day. Now the goal will be to figure out the position in the sky. Position in the sky. All right, so now I need to give you the other two pieces of information. All right, so we're going to figure out the position of the moon in the sky. I have to tell you the phase, and I have to tell you the time. So what will the phase be? I'm going to have the phase be waxing crescent. Waxing crescent. The time will be, let's see. The time will be, what will we do? Let's have it do it late. Let's do 10 p.m., something like that. So the question is, if I have a waxing crescent moon and it's 10 p.m., where in the sky would you see it? Is it high? Is it rising? Is it setting? Where would I see it? I draw a diagram. There's the Earth. Okay, day side, night side, it's waxing. I know where waxing crescent is. Here's new, here's first quarter, so waxing crescent is somewhere around in here, where we're mostly seeing the night side of the moon, but a little bit of that lit up side, so it's a crescent moon. And it's 10 p.m. 10 p.m. Okay, so here's 6 p.m., here's sunset, here's midnight. 10 p.m.'s got to be somewhere around over here. And look at that. The moon isn't directly overhead. That would be down here. The moon is this way. I'm just about to lose the moon. I'm going this way. I'm going away from the moon, so this must be west. And the answer is, if there's a waxing crescent moon and it's about 10 p.m., where will you see it? You'll see it over in the west, getting ready to set. So the answer is setting in the west. Every different phase of the moon rises, climaxes, and sets at different times of day. And so that's why there's this relationship between things. Every full moon rises at about sunset, is highest at midnight, sets at about sunrise. Every waxing crescent moon rises in mid-morning, is highest in mid-afternoon, and sets in late evening. And so using diagrams, we can figure out basically, this relationship between the position of the moon in the sky, the phase of the moon, and the time of day. All these calculations are all plus or minus a couple hours. They vary a little bit based on the seasons and details like this. But if we can do these diagrams and figure out roughly where things are, then I think we understand the phases of the moon and the relationship with that and the sun and the time of day in a very deep and substantial way.